third side here, I can represent that as 6 plus x. Okay, so let's keep going. 7 plus 18 greater than 6 plus x. Subtract the 6 over. So x has to be greater than, x has to be less than 19. So let's go to my choices, because you're going to find something interesting here. 25, ooh, absolutely not. All right, 25 is not less than 19. Sorry. What about 19? Interesting. Well, take a look. There's no greater than or equal to symbol here, so I'm not going to use 19. All right, it has to be less than 19, not less than or equal to. So 19 is out of the question. Now take a look. 5 and 12 both work. Well, take a look at 5. All right, 5 is definitely less than 19, but if I plug 5 in, that side now becomes 11. And remember what I said to you at the beginning of this problem, that the sum of two sides needs to be greater than the third, and that applies to every two sides, not just pick two sides and that's it. It has to apply to every two sides. So if you take a look back, 11 plus 7 gives me 18. That's not greater than the third side of 18. That's equal to 18, so I can't have 5. All right, so 5 is out of the question. It's got to apply to every side. So 12 is my remaining answer here. Okay, 12. All right, looks good for the triangles. I got one more triangle question on me, and this is a part 2 one, so this is what I was referring to in the opening about the open-ended questions where you have to show your work. Okay, again, this is number 29. All right, looking good. In the diagram below of right triangle ACB, altitude CD intersects AB at D. If AD is 3 and DB is 4, find the length of CD in simplest radical form. All right, before I even start any of this problem, I want to label parts of my triangle because that'll lead me into a couple more tips I'm going to give you about these type of problems. Okay, I have a right triangle. The big triangle is a right triangle. Okay, so the first of all, we got the hypotenuse here. Across from the right angle is the hypotenuse. The other two sides that are not the hypotenuse, we call the legs. All right, so I have leg, actually let's call that leg number 1 and leg number 2. All right, looking good. Now, the only thing I haven't labeled are AD and DB. I refer to them as the hypotenuse segments. So here's segment number 1 and segment number 2. Okay, here's my little trick. All right, when you have a right triangle with an altitude drawn to the hypotenuse, okay, it's either one of two kinds. I refer to it as a SAS or a Hills. Okay, maybe your teacher has used this as well. A Hills or a SAS problem. Okay, what's everything mean? Well, I'm sure you could guess just by how I've labeled it. The SAS is segment 1, altitude, altitude, and segment 2. Or you can use the Hills if you're dealing with the hypotenuse, a leg, or one of the segments. Okay? I'm not dealing with any of the legs on this problem. All right? It's no use to me, so I'm going to use the SAS. And how I use it is the following. It sets up the proportion you need to use. S over A equals A over S. Okay? Again, what did S mean? Segment 1. 3 over my altitude, CD, which the problem asked me to find, so 3 over X, equals altitude. The altitude is still X, that doesn't change, over the other segment, or in our case, segment number 2, which they give us is 4. Okay? Solving proportions, this is a little bit of algebra, what you saw yesterday. Cross multiply. X times X, X squared, equals 3 times 4, 12. How do I get rid of that little squared there? Square root both sides. X is equal to radical 12. Now, you think you're done, but make sure you go back and read the directions again, because I'm not done. The directions say simplest radical form. And I can tell you 12 is not simplest radical form, so we have to break it down. All right? We're going to break it down into the following. Find the biggest perfect square. What I mean by perfect square is 1, 9, 16, 25, and so on. That goes into 12 evenly. All right, so you do a little mental math right now, and you find that 4 is the biggest perfect square that goes into 12 evenly. 4 times what gives you 12? That would be 3. Okay, so I have 4 times 3. Square root of 4 is 2. Bring down your square root of 3, and there we have it. The altitude is equal to 2 radical 3. Okay, so hopefully this Hills and Sass helps you out a lot. And if you're still unsure, feel free to email me at rrlive@yahoo.com, and I'll explain it further if you'd like. All right, going to our second call of the day. Kay from Schenectady. Kay, how are we doing today?
Good. How are you?
I'm doing excellent. What can I help you out with today?
Yes. Hi. Can you do problem 21, please?
Problem 21, absolutely. Getting ready for the exam, Kay?
Yep.
All right. Problem 21. Okay, similar triangles. Way to bring this one in, Kay. We're on triangles right now.
I have a little bit of trouble with triangles. So.
Okay, you got it. Let's see if I can help you out. Okay, number 21 reads, in the diagram below, triangle PRT, Q is a point on PR, S is a point on TR, and QS is drawn. And we also know that RPT is congruent to RSQ. Once you're given something like that, what I recommend is mark it on your diagram right away. So RPT is congruent to RSQ. So right away, I have a pair of angles that are congruent in the triangles. And the question asks, which reason justifies the conclusion that triangle PRT is similar to triangle SRQ? Okay, let's first go over ways to prove triangles similar before I attack this problem. The first way you can prove triangles similar, and it's probably the most classic way, is angle-angle. If you can get 2 pairs of angles congruent to each other, you have similar triangles. The second way is side, angle, side. And sometimes you'll see the similarity symbol put next to it. Sometimes you won't. That's fine. And don't get this confused with the side, angle, side for proving triangles congruent. What this side, angle, side means is you have a pair of you have a pair of angles that are congruent to each other, but the sides are in proportion. 2 pairs of sides that have the same proportion. Okay? And the final way is side, side, side similarity. Again, you may see that similar sign or not. And what this means is all 3 pairs of sides are in proportion to each other. Okay, so what we have to look for is which one of these 3 could it be? Already from the givens, they give you a pair of angles that are congruent. Okay, so automatically, side, angle, side, sorry, you're a good way, but not today. So now I'm down to angle, angle, and side, angle, side similarity. Now, if you take a look here, Kay, both of these 2 triangles share an angle. They have an angle that's in common with both triangles. And that angle is angle R. And we say it's congruent to itself by what you might have heard as the reflexive property. Sound familiar, Kay?
Yes, it does.
All right, excellent. Okay, so what I have is 1 pair of angles, and here is my second pair right here, angle R. It's in both triangles, so it's congruent to itself. So I have 2 pairs of angles, angle, angle. All right, how'd we do, Kay?
Oh, I did good. I'm getting it. Thank you very much for helping me. I appreciate it.
Hey, no problem. Good luck on your exam, okay? Good luck.
Thank you very much. Bye-bye.
Okay. All right. Okay, next question. Get back here. Get myself back in order. Stick with me for a sec here, guys. Okay, we're going to move on to transformations now. Okay, our first caller asked a question about transformations with the composition. I'm going to get in a little bit more detail with the transformations as well. The first question I'm going to do is from the sampler. It's question number 3, multiple choice question. Okay. Triangle ABC has vertices 1, 3, 0, 1, 4, 0. And under a translation, so we're talking about a translation in this case, A prime, the image of point A, is located at 4, 4. Under the same translation, it's asking what would C prime be. Okay? So let's just write down what we're given. We're given point A is 1, 3. All right? and it's saying it's performing some kind of translation, capital T, all right? And our image is at 4, 4. Okay? So the first step to this problem is finding out what translation, what are you adding to your x's, what are you adding to your y's to get 4, 4. So let's figure that out first. 1 to 4, I'm adding 3. Okay? 3 to 4, I'm adding 1. So there's my translation already. All right? 3, comma 1. Now, I have to apply that to C. C tells me is 4, 0. So I'm going to perform the exact same translation I found, 3, comma 1. All right, we've been talking about this a lot, this program so far, is you add or subtract your x coordinates and your y coordinates when you do a translation. So the first thing I'm going to do is 4 plus 3 gives me 7. 0 plus 1 gives me 1. So C prime came out to be 7, 1, which is choice 1. Looking good. Another caller, Scotty from Del Mar. What's going on, Scotty?
Hi, Mr. Carlino. This is Scotty.
Hi, Scotty. What can I help you with?
I was wondering if you could help me with question number 17.
Question number 17.
Yes.
Okay, you got it. Circles.
Yes, I'm not too amazing on those circles.
No. Either some of my students, so don't worry. Okay, here we go. Number 17 is a circle question. It says, in the diagram below, PS is tangent to circle O at point S. And PQR is a secant. PS is equal to S, so let me write that down. PS is equal to X. PQ is equal to 3. And PR is equal to X plus 18. Okay, have you guys done circles this year, Scotty?
Yes, we just finished up the unit.
Oh, excellent, excellent. Okay, so we're dealing with a tangent and a secant. Anytime I'm dealing with the length of a tangent and a secant, here comes another tip for you, all right? Anytime tangents, or I'm trying to find the length of a secant, I tell my students to remember the following. Whole times external equals whole times external. And I'll get into give me a second here. I'll tell you what all this means.
Okay.
Okay? We're dealing with two things here, Scotty. We're dealing with a tangent and a secant. So what I want to do is whole secant, which I labeled as x plus 18, times its external part, aka the part on the outside, which is 3,
Okay.
equals, now I took care of my secant, now I'm going to take care of my tangent. Okay? And this is not a trick question here. This isn't a trick question here, but the whole tangent here is x. And now when I go to the external part, it's also x.
Oh, okay.
So the whole and the external are both x here. And now I have an equation I'm going to solve. All right? Let me get out here a bit. There we go. All right? So here we go. Going to distribute the 3. 3x, little human calculator here, 54, equals x squared. Okay? Now you got to do a little bit of algebra from last year. And all of you took the algebra Regents and passed it. Now that you're taking geometry. And you may see a couple questions where you have to use algebra from last year. So if I have a squared, that means I'm probably going to have to factor. So I have to get one side equal to 0. So I'm going to subtract 3x and subtract 54 to get it over. All right, so I have 0 equals x squared minus 3x minus 54. Now, shaking off the cobwebs here, how do we factor this? Well, we have our two parentheses, still equal to 0. I have x and I have x. Now, the goal is, you got to play a little game now, two numbers that multiply to 54 but add to -3 at the same time. So you go through your list of what numbers multiply to 54, and you come up with 9 and 6. I bet I can add to -3. All right? Mm-hmm. So now I got to say to myself, what signs do I have to put in front so these two add to a -3? put a -9 and a +6 on there. All right. Now I just have to solve it. X plus 6 equals 0. X minus 9 equals 0. Add 9 to both sides. X equals 9. And on this side, x equals -6. Now, two answers? I think not. All right, now that we're talking about a length of a line, I can't have a negative answer. So I'm going to have to reject that -6. So that -6 goes. Final answer, x equals 9. So that was a good question there, Scotty, because it used geometry from this year and a little bit of algebra from last year. So great question. Hope I helped you out.
Thank you very much,
Good
Mr.
luck on that
Carlino.
exam. Yep, good luck.
Thanks. Good job on TV.
Thanks. Gotta love my students. Okay. Let's keep it going here. We're doing real well today. Hopefully we're picking up a little tips as you go along. And we got one more transformation, a couple more transformation questions, excuse me. This one's going to be number 18 from the sampler. Okay, still deals with transformation, so we're shifting gears from circles to circles to transformations. There we go. All right, it says a polygon is transformed according to the rule xy shifts to x plus 2, comma y. Every point on the polygon moves 2 units in which direction? Okay, first off, let's get through this pretty quick here. The y's, nothing's happening to the y. Okay, so if you take a look at your xy axes, oh, put the x there, that's what I meant, and your y here, okay? Nothing's happening on the y-axis, so I am not going up or down, okay, because the y is still changing to y. So the only direction I'm moving could be left or right, okay? Now that it's being added to 2, all right, if you're adding on the x or y axis, you're moving to the right because you're moving towards the positive numbers, all right, adding positive numbers. If you were subtracting, we'd be moving towards the left. So since this is adding 2, I'm going to be moving to the right 2 units. Okay, so just a quick transformation one right there. Probably in there to confuse you, and maybe it needs to be tougher than it is. But no, all right, you're confident, you're good at this stuff, so nice, easy one right there to the right. Okay, all right, our next one is going to be another 2-parter. It's going to be question number 30. Okay, question number 30. This is going to be a big one here. Zoom out a little. There we go. Okay, the vertices of triangle ABC are A, 3, 2, B, 6, 1, and C, 4, 6. Identify and graph a transformation of triangle ABC such that its image, A prime, B prime, C prime, results in AB being parallel to A prime, B prime. So this one doesn't tell you exactly what to do. You kind of are up to your own decision on how am I going to keep those 2 lines parallel. And we'll talk about what transformation would be appropriate in this case. Okay, so the first thing I'm going to do here is get my straight edge. Let's graph this up. Okay, it doesn't ask me to do it, but I'm going to graph the original triangle because that's going to help me out tremendously. So 3, 2 is point A. 6, 1, 1, 2, 3, 4, 5, 6, 1 is B. Let me just make sure. 1, 2, 3, 4, 5, 6. Yep. And C is 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so there is my triangle. Okay, now you got to start thinking what transformations are going to have AB parallel to A prime, B prime. Now, this is a great question because it goes back to what I talked about earlier, which is parallel lines. And you know that if 2 lines are parallel, they're going to have the same slope. Okay? So what I need to find is what's going to keep the same slope for AB. All right, let's write our choices down for different transformations that I'm sure you've gone over this year. The first is a reflection. Okay? Second, I'm sure you've done rotations. So that's an option that I have. Okay? The third is one we've talked about already, a translation. That's a slide. And the fourth one I've also talked about with one of our callers is a dilation, where I multiply. Okay, so you're sitting there in the exam and you're saying to yourself, okay, which one of these four would keep the slope of AB the same? All right, and I'm going to go the easy route here, okay? A dilation, all right, using a dilation will keep the slopes the same. And the reason is, when you multiply the number, you're not changing the ratio of x to y. It's still staying the same because you're multiplying the same number to x and y. So a dilation will work every time. So what I'm going to do here is, I'm going to use a dilation, and you can pick any scale factor. So I'm going to keep it easy, like I said, and I'm going to do a dilation of 2. All right, so going back here, if I have a, 3, 2, if I dilate that 2, that'll be 6, 4. B, 6, 1. It's a dilation of 2. B prime now becomes 12, 1. Whoa, big one there. And C, 4, 6. Dilation of 2 becomes 8, 12. Okay, so I'm going to graph those points, and I'm going to show you that their slopes are still the same. So A prime is 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There we go. There's A prime. B prime, 12. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. Oh, make sure it's always good to go back and check your answers before you start here. Did a little mistake here. I'm surprised you guys didn't catch me. I'm sure you're yelling at home right now, but 1 times 2 is 2. Forget that human calculator stuff I said earlier, huh? Okay, so it should be at 2. All right, so forget this point. I'll cross it out. And that's another good point I want to bring up too. If you don't want who's ever scoring your exam to see what you wrote, put a big X through it, and they won't score it at all. They'll just score what's showing on the sheet. So if you don't want them to score something, just put a nice big X through it, okay? So there's B prime. C prime is 8, 12. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9,